Hello guys, in this video we are going to see about outlier and various outlier detection techniques. So whenever you take a data set, if any data point lies far away from the other data points, it is considered as an outlier. For example, let's consider a data set with features age and salary. So in this data set, we can find the feature named age and salary. In find various values. So for age 50, the salary is 2 lakhs. For age 40, the salary is 1 lakh. For age 30, the salary is 50K. And suddenly you can find a value as age is 500. Okay, so this is nothing but an outlier. So we know that so a person with age 500 is definitely not possible nowadays, right? So this is an unusual value, or it is an anomaly value, so this can be considered as an outlier. Similarly, if you find a person with age 200, again this can be considered as an outlier. Okay, so you can consider another example. So you can consider the data set with the marks of students. So for example, student 1 have got the marks 90, student 2 has obtained the marks as 100. So student 3, suddenly if you find a value as 500, so normally the marks range lies from 0 to 100, right? So 500 is nothing but a value which is out of range. So this 500 will be considered as an outlier. So these are few examples of outliers. So such kind of outliers should be removed from your data set. So in all the cases, outlays are not bad. So in some cases, the outlays are even good. For example, if you consider credit card fraud detection, so normally fraud transactions are very different from the normal transactions, right? So in such scenarios, outliers will be very useful for detecting the anomalies in your data set. Okay. So now let's see why it is necessary to remove the outlier from the data. Okay, so most of the machine learning algorithms will not provide good accuracy if the data set has some outliers. So whenever you come across with some outliers, it's better to remove the outliers. Even the outlier will be affecting the statistical properties of the data, like it will be affecting the mean standard deviation of your data set. So now let's see the different techniques used for detecting the outliers. So outliers can be detected using various visualization techniques as well as statistical techniques. So the first technique which we are going to discuss is box plot. Box plot is most commonly used for detecting outliers. So it is constructed from 5 values, namely minimum value of your data set, maximum value of your data set, first quartile, which is nothing but Q1, median value, third quartile value. So using these 5 values, the box plot is constructed. So any values which lies below this lower whisker end and above this upper whisker end will be considered as an outlier. So in this diagram you can see, right? So this point is considered to be an outlier since it lies above the upper whisker end. Okay. So this denotes the your minimum point. So this denotes the Q1, which is first quartile. So first quartile in the sense 25th percentage of your data. Median represents the middle point of your data. So Q3 represents the 75th percentile of your data. Okay. So this upper whisker end, this denotes the maximum value of your data. Okay. So any value which lies above the upper whisker end and below the lower whisker end is considered to be an outlier. Even you can use a scatter plot for detecting the outliers. So whenever you come across any numerical data and you have a paired numerical data, so when your dependent variable has multiple values for each independent variable, so you can make use of the scatter plot. So normally scatter plot is used to determine the relationship between two variables, right? Any kind of numerical variable. So in this graph you can find the maximum data points are lying in the bottom left corner of your graph, right? But only few points lies in the top right corner of the graph, right? So these points are considered to be the outliers. So the data points lies far away from the other data points. So this will be considered as an outlier. So whenever you have some numerical data and whenever you try to find the relationship between the numerical data points, by means of scatter plot, you can easily detect the outlier. The next statistical method used for detecting the outlier is set. So set score is also known as standard score. And whenever you are using a set score, it assumes that your data set follows Gaussian distribution. So Gaussian distribution in the sense, it assumes that your data set has mean is equal to 0 and standard deviation is equal to 1. Okay, so whenever you have some data with mean is equal to, for example, consider mean is equal to 3 and standard deviation is equal to 2 or any other value. So in case if you want to convert this data into an Gaussian distribution, so you can make use of the set score. So the set score is given by any data point minus mean divided by standard deviation. So this is the formula of set score. So by using this formula, you can convert any kind of data to Gaussian distribution. So it's normally assumed that 99.7 percentage of your data point lies in between minus 3 standard deviation and plus 3 standard deviation. So any value which lies above this 3 sigma and below this minus 3 sigma is considered to be an outlier. So you can find the z-score value of a data and you can set a threshold as 3. So the data whose z-score value lies above 3 and below minus 3 can be considered as an outlier. So the next statistical method which is used for detecting the outlier is interquartile range. So IQR. IQR is nothing but the difference between the 75th percentile of your data and 25th percentile of your data. So it's normally considered that, so in any data set, Q1 is considered as the 25th percentile of your data. So Q3 is considered as the 75th percentile of your data. So the difference between this Q1 and Q2 is considered as the interquartile range. So IQR is given by Q3 minus Q1. Okay, so any value which lies above Q3 plus 1.5 into IQR and below Q1 minus 1.5 into IQR is considered to be an outlier. Now let's see how to detect the outlier and remove the outlier with the help of a data set. I have taken a data set named weight, which is a CSV file. So it is having the features named gender, height and weight of different people. So let me read the data set. So for reading the data, we need pandas library. So I'm importing the pandas library initially and let me read the data. So it's a CSV file. So we have to use the command pd dot read underscore CSV. The name of my file is weight. So weight.csv. So let me print the head of the data frame. So I can find the features named gender, height, weight. So let me check the null values, whether any null values is present in the data set. So you can find that there are no null values. So null values in the data set is equal to 0. Okay, so I'm going to detect the outlier using two different methods. So first method is by means of set square and by means of interquartile range. Okay, so in order to find the set square, I do not recur this categorical column. So I'm going to drop the categorical column. So df dot drop of gender, I have to mention the axis. So it lies in the column. So I have to mention the axis is equal to 1 comma in place is equal to true. So if I did not pass this in place is equal to true, the changes will not be reflected in the original data frame. So let me again print the head of the data frame. So you can find the data frame with the gender column dropped. Okay, so now let me create a copy of the data frame. So I'm going to use two different methods, right? So I'm going to create a copy of the data frame. So first method I'm going to use is set score. So first let's check whether the data frame is having any kind of outliers. So I'm going to use box plot. With the help of box plot we can find whether any outliers are present in the given data. So df dot box plot of is used for plotting the box plot. So here you can find, right, the features height as well as weight is having outliers. So the feature weight is having some values above the upper whisker end. So this is considered to be an outlier. Similarly, the height is also having few outliers below the lower whisker end and above the upper whisker end, right? So these outliers has to be removed. So first method I am going to use is set score. So before calculating the set score, let's print the shape of the original data frame. So the shape of the original data frame is 10,002. So 10,000 rows as well as 2 columns. Okay. So now let's find the set score. So set score can be found using an inbuilt function which is present in the SciPy library. So let me import the SciPy library first. So from SciPy, I am importing stats library, or if modulus z is less than 3, it can be considered to be an outlier. Okay, so I am going to find the absolute value or modulus value of the set score of each elements of the data frame. Okay, so I am going to name the set score values as a variable z. So stats. So in order to find the absolute value, I need the numpy library. So let me import the numpy library. So import numpy as np. So z is equal to np.abs. So this will provide the absolute value of set. So stats.set square. So an inbuilt function is present in the stats library. So this set score function will be calculating the set score value. So set score of df. Let me print the set score value. So I can find all positive values. So since I have found the modulus value or absolute value, you can find all positive values for set score. So now I am going to filter the values which satisfy the condition set less than 3. So I am going to filter the data frame. I am going to apply a conditional filtering. So I am going to keep the values of the data frame which satisfies the condition modulus z less than 3. So apply the condition. So z less than 3, and I have to apply this to all the elements of the data frame. So I am using this function dot all of. It is applied to the column values. So you have to mention this axis is equal. Let me print the data frame df1. Okay. So let me check if you can find the shape of the data frame, right? So initially the shape of the data frame was 1000 rows and 2 column, right? So here now you can find the shape of the data frame as 9993 rows. The meaning is the outliers which are present in these 7 rows has been filtered out. So now your data frame has the values which satisfy the condition set score which is less than 3. So all the values which have the set score above 3 has been filtered out. So this is how you detect the outlier using set score and remove it. So now let's see the second method, how to use interquartile range for detecting the outliers. So let me create another data frame, copy of the original data frame named df2. So let me print the head of the data frame. The interquartile range, we need to find the value of Q1, which is nothing but the first 25th percentile of data, as well as Q3, which is nothing but the 75th percentile of data. So you can find those quartile range values with the help of the data frame. So let me name the first quartile value as Q1. So df1 dot, you have a function named quartile. So this quartile will provide the any quartile value, let it be 25th percentage or 50th percentage or 75th percentage. You have to mention the percentile value which you require. So here I require the 25th percentage, okay, percentile value. So I am passing the value as 0.25. So this will provide me the 25th percentile of the data. Okay, similarly I need to find the 75th percentile of data, right? So df1, sorry, this is not df1, it's df2. Okay, so df2 dot quartile of 75th percentage. So pass the value as 0.75. So let me print the value of q1. So 25th percentile of feature height is 63.5 and 25th percentile of the feature weight is 135.8. Let me print the third quartile value. So this is the values of third quartile. So now let me find the difference between the Q3 and Q1, which is nothing but your interquartile range. So IQR is equal to Q3 minus Q1. So let me print the value of IQR. So these are the values of IQR. So now we know the condition, right? So if any values which lies above Q3 plus 1.5 into IQR will be considered as an outlier. Similarly, any values which lies below Q1 minus 1.5 into IQR will be considered to be an outlier. Okay, so we need to filter these values. So from the data frame DF2, we need to filter these values. So any values which is above Q3 plus 1.5 into IQR and any value which lies below Q1 minus 1.5 into IQR has to be filtered. So I'm going to apply the conditional filtering and I'm going to say this as a new data frame. So let me say this is df2 underscore new. So let me apply the conditional filtering. So let me filter the entries of the data frame df2 which are below Q3 plus 1.5 into IQR and above Q1 minus 1.5 into IQR. So these are the values which are not outliers, right? So I will filter the values which lies above this condition and below this condition. Okay. So let me name the new data frame as df2.new. I'm going to filter the values of df2. So df2 of, let me apply the condition. So first condition is the values of df2 should be greater than or equal to q1 minus 1.5 into IQR. Okay, so since the values which lies below this q1 minus 1.5 into IQR is considered as outlier, I am filtering these values. I am keeping the values which satisfy this condition, which has to lie above q1 minus 1.5 into IQR. Okay, again I am going to apply another condition. So it has to satisfy two conditions, right? So I am going to use AND operator. And my second condition is df2 has to be less than or equal to q3 plus 1.5 into IQR. So this is the second condition, right? So this has to be applied to all the element of the data frame. So all of x is equal to 1, which represents the column. Now let me check the shape of the new data frame. So df2 underscore new dot shape. So you can find that initially the shape of the original data frame was 10,000 comma 2. So you can find 8 rows, which 8 rows has been deleted in this new data frame, right? So 8 rows which has the outliers has been removed. In case if you want to check whether any outliers is present in this data frame, you can make use of this box plot. So df2 underscore new dot box plot of. Okay, so now if you check the box plot, you can find there outliers has been removed in the box plot, right? So we have used two different techniques for detecting the outliers, namely Z score and IQR, and we have seen how to remove the outliers. That's all guys, thank you.